Good morning, everyone. I'm myself Hafirami. Today I'm here to present about my project, and my topic is image compression using PCA, Principal Component Analysis. And moving to the abstract, the aim to use the PCA is to reduce a file size or an image size while maintaining the visual quality. And the steps involved in this are flattening image data, applying PCA, and reconstructing the image. Coming to the introduction, our problem is to balancing the image size reduction and the quality preservation. And solution is to PCA identifies essential image features for efficient representation. And the applications are digital photography, medical imaging, and satellite imagery. And the methodology of overview are image representation. Since the image is represented as a matrix form of image pixels, and pixels are the data points here. And when we apply the PCA, it decomposes the image into principal components and project it into a new orthogonal axis. And third step is compression, that is retaining key components for efficient storage. And fourth step is reconstruction, that is rebuilding the image from selected components. And evaluation is the final step. And coming to the step by step methodology, first of all, since I say that image is represented in a matrix form, so the data points are pixels here. So first step is to calculate the mean of the features or attributes. Then we construct the covariance matrix. Covariance means the spreading of data points. That is, covariance can be calculated by taking the difference between each data points with this mean, and dividing it with the total number of data points. Uh, Suppose the data set have two attributes x and y, then to find the covariance between x and y will be given by or calculated by using summation of x minus x bar into y minus y bar by total number n minus 1. And by calculating this covariance matrix, we have to reduce that matrix into echelon form, row reduced by echelon form. We will get a eigenvalues. Eigenvalues means magnitude of the new data points, and by using or substituting this eigenvalues in the covariance matrix, we can calculate the eigenvectors. And after calculating the eigenvectors, we transform the data points into new axis by multiplying this eigenvector with each data point. Then this newly constructed or reconstructed data points can be represented in a new orthogonal axis. These are the step-by-step methodology of applying the principal component analysis. And moving to the image reconstruction, there are three steps: process, post-processing, and evaluation matrix. And in process, multiply reduced data by transformation matrix. That is, eigenvector is calculated with each data point to calculate or reconstruct the newly transformed data points. And in post processing, reshape the data and adjust intensity range. And evaluation metrics are mean squared error, compression ratio, and PSNR. And coming to the Python code implementation, here import numpy as np. First three steps are the packages from sklearn to import principal component analysis. And PC is a feature reduction technique, so it is under decomposition. Then coming to the fourth step, image, since we have taken one image here, or either we have taken one image or a set of images. So here I taken only one image. So image is equal to read the image, we import the matplot library. It is a Python library. So plt dot image read, we should copy the path of image. And here the image should be reshaped into a new axis, because after transforming the data, these data points are represented in a new orthogonal axis. And to apply the PCA is equal to PCA of number of components equal to 50. Here 50 is optional, because number of components can either be none or any value. If we given the none for number of components, it will kept all the components according to the feature of the image we have taken here. And next step, a reduced image can be fit into PCA. So for that, PCA dot fit transform our image, and the reconstructed image can be showed by printing the inverse transformation, because eigenvector transpose is multiplied with each data point to transform the data. So we have to print the inverse of that matrix. And next step is to image reconstructed equal to x reconstructed dot reshape. That step is to reshape the image. And next step, plt dot figure means figure size of the figure can be mentioned in that step. And here the printing options can be given in two subplots. In subplot 1, mm, we should show the original image, and in second plot the image after applying the PCA has been shown. So these are the Python code implementation. And coming to the result and analysis, here are two analysis, that is compression ratio and quality metrics. Compression ratio is to improved by reducing components, and quality metrics are lower mean squared error for better reconstruction, and higher PSNR for image quality assessment. And we can conclude it by PC as an effective image compression technique and trade-off between compression ratio and quality that is suitable for storage limited applications. And here are the limitations of PCA, that is combine PCA with other techniques for better results. And PCA's linear assumptions may not capture complex patterns and high computational overhead for large images. So thank you.